project planning, precedence tables, and activity networks. So when we are completing a project, we've often got a lot of activities that need to be done, and there's some that can't be performed until other activities are complete. So in preparing for this video, I prepared this little piece of paper. That didn't require me to do anything else, but I also had to set up my webcam and the broadcasting software, and I've got to get the broadcasting software going before I get the webcam on. And so two different things had to happen before I start filming, and some depended on the other, some didn't. So an activity network is like a graph, but we mark the activities on the edges, not the vertices. Well, activities. A precedence table is like this little one down here, which shows the activities involved in a project and any immediate predecessors, which is an activity that has to happen before this activity can occur. So a precedence table there we go. So an immediate predecessor, of course, is an activity that has to happen before the next activity. And we sometimes have the need for a dummy activity, and that is if I have to have one activity feeding into two others, and I've got no other way of having an edge going to both other activities. I'll see if I can find a different way of defining that. A dashed line used when two activities share some predecessors, and I'll probably do a separate video where I go into dummy activities. So we need to be able to construct an activity network from a precedence table. Now you can work start to finish or finish to start. You might like to try doing a couple of different ways. So basically, any activity that isn't an immediate predecessor, so H is not a predecessor for anything else, means that H is going to lead to the finish. Any activity that has no immediate predecessor follows from your start vertex. So we've got a start and a finish vertex, and our network connects those two. So for every other activity, we've got to work out what it's an immediate predecessor for. So A is an immediate predecessor for B, meaning we have to do A before we can do B. We've also got to look for any that it's required for as an immediate predecessor. So C is an immediate predecessor for F. So we start putting together this information. This one will start from the back because we can see that H is not an immediate predecessor for any other activity. Nothing's relying on H, so that will lead to the finish. Put our finish, sorry about my writing today, finish, and direction thing happening there, H. Now, H has three immediate predecessors. So E, F, and G all need to be done before H is. E, F, and G all have different immediate predecessors, so we shouldn't get too complicated in there. We can just feed E, F, and G all into H. So H now has E, F, and G feeding into it because they have to be done before H can happen. Then we look at each of these. So activity G, for that to happen, activity D needs to have happened. And for D to happen, A has to have happened. So at this point, we might start saying, all right, let's get D happening, but for D to happen, A has to happen too. And A has no immediate predecessors, so we're starting at A. All right, so we've got D in. Now what about F? F needed C. C needed A. So once A is done, C can happen, and then F can happen. All right, we need E. E relies on B. B relies on A. So once A has happened, then B can happen. I'm running out of space here. We'll lengthen E a bit. And then it's a good idea to run through and just check, have you covered everything? Work through the other way. A doesn't rely on anything, so from start we do A. A lets us do B, C, and D, so B, C, D all have A as an immediate predecessor. E relies on B, F relies on C, G relies on D, and they all feed into H. We can also work back the other way. Reading this table, or network, we can make a precedence table. But that's a little introduction. I'll do a later video on dummy activities. That should be enough to get you going.